even though if we don't reach some sort of super powerful intelligence, which I'm afraid to get there, the AI that we have today are already really powerful. And especially for processing large chunks of data, which take us a lot of time. On today's show, we're exploring a historical moment where the 2024 Nobel Prize in Physics was awarded for advancements that bridged physics and artificial intelligence. That's right, this year the spotlight shines on Geoffrey Hinton and John Hopfield for their groundbreaking work on artificial neural networks, the very foundation of modern AI.
So, Daniel, the Nobel Prize of this year, 24, in physics was awarded to John Hopfield and Geoffrey Hinton for their groundbreaking work that helped create modern AI, which is pretty much impressive. So, Hopfield developed a system called Hopfield Network, which works like a computer's memory, storing and recalling information. Hinton created important methods like backpropagation and the Boltzmann machine, which allows AI to learn patterns and make decisions on its own. Their work laid the foundation for neural networks, computer systems that are designed to mimic the human brain, or that power tools like Google Translate, facial recognition, and medical diagnosis net software. Their discoveries combine physics and AI, helping machines handle complex data and solve tough problems in many areas, such as studying particle collisions in physics or understanding molecules in biology. So, both scientists warn about the risks of AI. Hinton has raised some concerns about AI and the ethical guidelines, and their work has not only advanced technology but also highlighted the need to balance innovation and responsibility.
Yeah, like basically, as far as I know, when neural networks were invented or they discovered this way of processing information, that was like a groundbreaking discovery that speed up AI development, and it brought us or allowed us to be where we are today with the large language models. A key scientific breakthrough that let AI to evolve to the shape that we have it today.
Yeah, it's amazing to see how Nobel Prize is like rewarding these discoveries. So I feel that these kind of innovations, and Hinton is the godfather of AI, as you mentioned. Like it's such an important and remarkable year today, I think.
So perhaps we can talk a little bit about what neural networks are.
Yeah. So actually, neural networks are computational models that are inspired by the human brain, designed to recognize patterns and learn from data. So it kind of simulates the way that we mimic our thoughts. And I think you know a little bit more about it, isn't it?
Yeah, I mean, nothing that much different from what you just said. So I think the difference, the key difference is that it tries to mimic how the neurons work in our brain. So it's not a linear process. So they connect to it to several nodes until they get to a different output. So this more complex way of solving allow neural networks to handle more complex tasks like image recognition and natural language understanding, which a lot harder for traditional algorithms to solve.
And taking into consideration that, like, how do you see that the Hopfield network and the Boltzmann machine contributes to an AI evolution?
I think the Hopfield network introduced the concept of associative memory, where patterns can be stored and retrieved even if they are noisy or incomplete. So the concept basically mimics how human memory works, and and became like a stepping stone for modern AI, to my understanding. And the Boltzmann machine developed by Hinton use probability to learn from data without explicitly programming. So this early neural network demonstrated how AI could interpret complex data sets, influence like deep learning models that came after. So based on all of that, what do you think are the real world applications that have emerged from this foundational AI advancements?
That's a really good question because everything that we are using in a daily basis, for example, Google Translator, it comes from this network and these advancements. Image recognition, for example, if you see a cat and then or take a photo of a cat and then Google said to you that it's a cat, or even other programs, they are all comes from the same technology advancement. The medical diagnosis, for example, if you all these scans, that found disease. And I have read an article that now it's possible to see the breast cancer like years ahead, before it developed itself, like in the future. So thanks for this technology. So that's really interesting. And when we talk about data sets and databases and how complex it is to analyze this data, it's a really good advancement for scientific research, I believe, because then we can process all this data super quickly. And then actually what's have been done in the chemistry Nobel Prize, they did some advancements in minutes that they took like decades to do it.
That's the power of AI processing data, right?
Yeah,
I
which
think
it's amazing.
even though if we don't reach some sort of super powerful intelligence, which I'm afraid I'm afraid to get there. The AI that we have today are already really powerful, and especially for processing large chunks of data, which take us a lot of time and saves us a lot of time as well.
Yeah, that's true. That's true. And we use AI like in a daily basis, and it's really good. If, for example, if you take some press release or some like documents from how to call this annual reports from the companies, they're super complex. Sometimes they're like 50 pages of stuff, and then you sometimes it's only a few of the information there. It's good for you, so you can use AI to interpret all this data and give you only the important aspects of this document. So for me, it's I cannot live without AI anymore, to be honest.
I haven't seen any report that mentions how many companies are actually using AI to analyze reports like that. But I can take a guess that everybody that implemented AI, or every company that implemented AI inside, is probably using this to interpret this kind of stuff, because it's otherwise they're just wasting potential.
Yeah, definitely.
How about we talk a little bit about the ethical challenges that came from these advancements in neural networks? Do you want to talk a little bit about that?
Yeah, I have seen that some data coming from HRs, they are selecting people through some specific standards. And then, for example, there was a company that they were feeding the AI only with men, and then the AI was selecting only men, for the roles, even though women were like in the same level of men in terms of education and background. So these kind of things can be pushed by AI, so AI can create this bias preset.
Yeah, when the data is not good or it's not fair, then of course you're gonna end it up like with a model that is also biased towards that data, right? So we also need to be very mindful when we train these models.
So autonomy and control. I think we already discussed here in the podcast that maybe we are creating something that more intelligent, and maybe it can be uncontrolled, in many ways, creating their own language. So maybe the machines will talk to each other without we, all of us humans understanding their language, or even taking decisions. For example, global warming is because of humans' existence, so they will just cut us from the equation. Stuff like that that we don't know what can happen.
I think that reminds me of an interview that I saw with Geoffrey Hinton, the Nobel winner,
Yeah.
about yeah, that he doesn't think that you need to have like a very intelligent AI to create a lot of disruption for, you know, something bad happen. You just need autonomous AI. So basically, if you have an AI agent, which we're like pretty close to get, according to all these big AI companies and how they are promoting themselves now, which you have to take it with a grain of salt because they also want to raise a lot of money to continue investing in the product. But what he said in this interview, maybe we can link to the show notes because it's quite interesting, is that when you have an AI agent and then it has a goal, in order to achieve that goal, you will, let's say, you want to buy tickets to go somewhere. But in order to do that, you have to do several sub goals. And when you define these sub goals, that's where the danger is because you can create sub goals that can have a lot of impact. And those machines, they want to be as efficient as possible. They want to get to the end result as fast as possible to deliver you what they were asked. And sometimes they have to take they will take shortcuts, and these shortcuts maybe are sub goals that are colliding with us, or we might be on the way, or let's say if they, in order to achieve their goal, they need more control, they will try to get more control to be able to achieve that goal. And then that's where it gets dangerous. I think I ramble a little bit, but the point is that in order to get to the goal, they might want more control because they know they can, if they get more control, they will achieve that goal faster. So that's where the danger lies if we don't have some guardrails around these technologies and can prevent them from getting all the control they need. Yeah.
And I can give another example of. I always think about these algorithms from social media. They're creating a lot of issues in our world. This kind of when they create these bubbles, and it's created automatically by social media. So it's giving you information about something that you like, and then when you see you're super extreme, for example, in one side of politics or another side, and then it kind of disrupts. So we're seeing in the politics in many places in the world, like people are becoming more fanatic and stuff. And I think the algorithm is already doing some stuff, because automatically is putting us in these extreme bubbles. So even a small technology, not a small technology, I think it's an amazing technology, but it's an autonomous technology like that, like the algorithms from social media, can already have a really big impact in our daily life. So what can a super machine can do?
Yeah, exactly. So there's also, of course, some job related issues, right? I guess we've been talking a lot about that, and then there's no way going around that AI will create some disruption in jobs as well. And I think him to have been quite advocate in regards to that, like saying that there are uh, some fields where there will be some elasticity, so you potentially be able to adjust or adapt, and then humans will still be needed. But there are some jobs that will be automated because instead of taking 25 minutes, it will take 6. So
How has Hilton's backpropagating algorithm influenced modern AI systems like ChatGPT and AlphaFold?
So, Hinton's backpropagation is a process that allows neural network to learn by adjusting weights based on errors on their output. So basically, they're training themselves. So it's very fundamental. Was very fundamental to train deep learning models, for example. And without it, like systems like ChatGPT wouldn't be able to process language, and AlphaGo wouldn't be able to play Go, which is, by the way, Go is a Chinese. Maybe it's considered one of the oldest games, board games in the world. It's called Go, and I think it was AlphaGo that basically was the technology or the AI to beat it. And just to put a little bit of context, because I read a little bit about it, when they were testing this, the the AI algorithm AlphaGo learned to play Go, which is apparently is a very hard game because it's so strategic. There's so many different ways, in different ways than humans have been played for centuries and millenniums. So nobody expected that the computer would just find those shortcuts. So it beat it humans in a very dramatic way. So it's quite interesting. So yeah.
No, it isn't, and I think it kind of relates with the first chess model that beats the the champion. You know, this the biggest champion in the chess in the world. Like it was beaten by a computer back in the 90s. So that reminds me exactly like these kind of models. So that's pretty much interesting. Should we try to play Go? Should we?
Oh, we can just ask AI to do it.
Yeah.
So how do you see the blending between physics, neuroscience, and computer science shaping the future, looking into the advancements in AI and then the base, which is neural networks?
I think AI it's an amazing way of solving complex problems and connecting all these fields. You know, I think it makes more reach. So physics provides, for example, mathematical frameworks. Neuroscience inspires the design of learning algorithms, and computer science implements them at scale. You know, so it scales up the. So I think it all merges together. Everything it's kind of and this synergy drives to innovation in the healthcare, climate science, and beyond. You know, in many different areas. So I think the future of AI is collaboration between different disciplines and enhancing its transformative potential. I think we talked about that a lot in the podcast, how we can use in different areas and how can we broaden this knowledge, the many knowledge with AI. And I want to ask you, like I know that you have seen some stuff about Hinton's. Uh, what about Hinton's concern about safety? What do you think about that? Or how what can we learn from him?
Yeah, he has been very advocate about safety around AI because he's really scared that we're gonna create something that will lose control of it. So he has been talking in different. I think I've seen different interviews with him where he was talking about that one good way to try to enforce safety is to, instead of taking about using part of the budget or part of the revenue of these big companies into safety, his approach seems more logical because it then taps into the bottleneck of the technology, which is computational power. So in his suggestion, 1/3 of any AI computational power, any AI company computational power should be used for safety, to look into what kind of guardrails, what kind of protection can we put, or constraints can we put to this model so they don't go out and start spreading and create, and potentially can create problems, some problems for us in the future.
I think it's something that we need to be concerned and be taking into consideration all these things, because if we don't regulate it, I think something that he always emphasizes, regulate AI, it kind of and monitor its applications. It will ensure that human values are in the first point, so we don't take out all of this humanity that we have, and that's the dangers. I think that you highlight that really well. That's the dangers that are placed in the table now if we don't take care of the safety and take care of the how AI is evolving without anyone taking care of it.
Right now, we're in this arms race where everybody wants to be the first one to have a groundbreaking revolution with AI agents, or super intelligence AI. So it's quite complicated. So it's hard to see this thing slowing down if we don't regulate it accordingly. So, what do you think are the broader implication of recognizing AI pioneers, basically, with Nobel Prizes? What do you think
I
about
think
that?
I think it's a remarkable thing, and I think awarding Nobel Prizes to AI pioneers elevates public awareness about AI, and its transformative power. And I think it kind of legitimates AI as a tool for scientific advancements. And I think it kind of raises questions that we were discussing here, for example, safety and how can we avoid like misused or even in how can we address like inequalities or even like global warming through AI driven solutions, So I feel that that's the way that we should talk about that, like if we elevate these guys because we're leaving the advancements that these guys were like doing in the background, like in a couple of decades ago, they started with that. So now we are really having amazing advancements with that. So
So yeah, I think it's pretty interesting that Nobel this year have basically awarded like two different AIs in two different fields. It really shows that this technology is making waves, and we should be more aware of it. And then we should also see this as recognition that this is here to stay. So we reached the end of our episode. If you enjoyed the show, please consider leaving a review on Apple Podcasts. It's free and helps us a lot. This way, it can help us also reach new listeners. Oh, and if you haven't already, don't forget to subscribe on your favorite podcast platform to stay up to date on our latest episodes. If you have any questions for us, reach out to us at hello@humanaixp.com or connect with us on Instagram. Thanks for listening. See you next week.